Hello, I am Juliette Shelton, and this is my video lab report for Lab 2, Lines of Charge. In this lab, we are looking at a new method of calculating electric charge of a charged object. So in this lab, we are trying to determine how two charged objects interact with other neutral objects, other charged objects, and with each other. We will use pieces of tapes to record these interactions and to find the charge Q needed to make a suspended piece of U-tape float above another charged piece of tape at a measured distance. Except the difference between this lab and Lab 1 is that this time we are not treating them as a point charge, but as a line of charges spread evenly across the length of the tape. We want to analyze charges in everyday objects and demonstrate the effects of Newton's second law. So some fundamental principles that we are using in Lab 2 are electric field and electric force, Coulomb's law, Newton's second law, and the superposition principle. So some assumptions that I made for this lab. The first one is that charge is spread evenly across the length of the tape. And the second one is that charge on top is equal to the charge on the bottom of the two tapes. So the application of the principles we are using, Coulomb's law, that is like charges repel and opposite charges attract. And then the superposition principle tells us that the net force on an object is the sum of all of the forces acting on that object. And an electric field created by a charged object does not affect the electric field created by a different charged object. And then for the electric fields of line charges, first we're going to break up the line charge into many point charges, and then the lower point charges will act on the upper point charges. So some observations that we made in Lab 1. The two pieces of U-tapes repelled each other. The U-tape attracted to neutral objects, that being the book, my hand, the desk. And this is due to the induced dipoles from the U-tape's electric field. And then the U-tape attracted to negatively charged objects. This was the pin after it was rubbed in my hair. And that allowed us to conclude that the U-tape is positively charged and creates a negatively induced dipole when in contact with neutral objects. Then measurements and calculations. So the first few measurements are measurements that I found in Lab 1. But then the last calculations were all from this lab. So the length of my tape was 0.21 meters. The mass of my tape was 0.0002 kilograms. The distance between my two pieces of tapes was 0.012 meters. The gravitational force was 0.0019 newtons. The electric force was 0.0019 newtons. And then the charge of one piece of tape using our new method was 5.4 times 10 to the negative 9th coulombs. So then I used VPython to model this lab, and each piece of tape is modeled as a line charge instead of as a point charge. So first I added all of the constants and values. And then that first function you see, I added this function to create an E field based on a charged particle in an observation location. I then updated the locations of the line charges to be based on the total displacement of the two pieces of tape from my experiment. I then gave each piece of tape a length in the X direction. And then I updated my scale values in order to make my model visible after being run. So then the for loop that started in the last slide and continues here. This section of code iterates through every piece of charge. So 10 in this case on the piece of tape. It calculates the electric force on the top tape due to the bottom tape and creates individual arrows based on the electric forces. And then finally, we construct the net electric force and gravitational force arrows and print out the magnitude of each. So then we look at the computational model. The green arrows represent the individual electric forces from the pieces of bottom tape on the pieces of the top tape. The red balls represent the pieces of the top tape. The blue balls represent the pieces of the bottom tape. The white arrow is the net electric force, and the yellow arrow is the net gravitational force. So then for the conclusions for this lab, we were asked, what if you had modeled each of your tapes as a single point charge like in the previous lab, and to compare these estimated values of charge. So if we had measured it as a point charge, I would have gotten the same value I got in Lab 1 for the charge, which was 1.4 times 10 to the negative 9th coulombs. But that is opposed to my more accurate value based on the continuous charge model that I solved for in Lab 2, which was 5.4 times 10 to the negative ninth coulombs. The line charge was larger than the point charge. And then we were asked, why do these estimates differ and which value is more likely to be closer to the real value? So these estimates differ due to the different methods of calculation. The line charge method has a more accurate model as it includes both an X and Y component when describing the force on the top tape by the bottom tape, whereas the point method only is calculated and modeled with a Y component. So the line charge formula is more accurate because it includes a summation of many pieces instead of just one point.